In previous video, we have discussed about the order of chemical reactions. And today we are going to discuss about the elementary and complex reactions. So what type of reactions are known as elementary reactions? Elementary reactions are completed in a single step. In an elementary reaction, reactants are converted into product only in a single step. But in those chemical reactions, reactants are converted into product in a sequence of steps, in a sequence of elementary reactions are known as complex reactions. So the reactions taking place in one step are called elementary reactions. When a sequence of elementary reactions gives us the products, the reactions are called complex reactions. So what is the difference between elementary and complex reaction? Very simple. Elementary reactions are completed in a single step. In an elementary reaction, reactant is converted to product in a single step. But in a complex reaction, reactants are converted into product in a sequence of steps. In a complex reactions, an intermediate is produced between the reactant and product. But there is no formation of intermediate in an elementary reactions. So elementary reactions are completed in single step, but complex reactions are completed in a sequence of elementary steps or elementary reactions. So these are three examples of elementary reactions. This compound is ammonium nitrite. When ammonium nitrite is heated, decomposes to nitrogen and water. It is an example of elementary reaction. It is completed in a single step. Hydroiodic acid decomposes to hydrogen and iodine is an example of elementary reaction. Nitric oxide reacts with oxygen, produces nitrogen dioxide, also an example of elementary reactions. So elementary reactions are completed in a single step. So it is an example of a complex reaction. In this reaction, hydrogen peroxide reacts with iodide ion in an alkaline medium, produces water and oxygen. So it is a complex reaction. Why it is a complex reaction? Because this reaction is completed in two sequence of steps. It is completed in two sequence of elementary reactions. So elementary steps for this complex reaction is, first one, hydrogen peroxide reacts with iodide ion, produces water, and this is an intermediate. Intermediate ion is produced. In the second step, hydrogen peroxide again reacts with that intermediate, produces water, iodide ion, and oxygen. So in a complex reaction, an intermediate is produced. In a complex reaction, reactants are converted into product through the formation of an intermediate. So it is a complex reaction. So it is an example of a complex reaction. Why it is a complex reaction? Because this reaction is completed in how many sequence of elementary reaction? It is completed in two sequence of elementary reactions. So those chemical reactions are completed in a sequence of elementary reactions are known as what? Complex reaction. So it is an example of complex reaction. So next topic is molecularity of a reaction. So what is the molecularity of a reaction? It is the number of molecules that come together to react in an elementary reaction and is equal to the sum of the stoichiometric coefficient of the reactants in this elementary reaction. So what is the molecularity of a reaction? The total number of reactant molecules come together to form the product in a chemical reaction is called molecularity of the reaction. So it is the number of molecules that come together to react in an elementary reaction is called molecularity of a reaction. And molecularity of a reaction is equal to the stoichiometric. Molecularity of a reaction is equal to the sum of the stoichiometric coefficient of reactants in the elementary step of the reaction. That means particular एक reaction में, particular एक elementary reaction में जितना टोटल रिएक्टेंट मॉलिक्यूल्स केमिकल रिएक्शन में पार्टिसिपेट करता है फॉर द फॉर्मेशन ऑफ प्रोडक्ट इज कॉल्ड मोलिकुलरिटी ऑफ द रिएक्शन. So molecularity of a reaction is related to elementary reaction. Molecularity is not related to complex reaction. Molecularity term is related to elementary reaction. एक elementary reaction में, क्योंकि there are two types of reaction, complex reaction and elementary reaction. एक elementary reaction में जितना total reactant molecules react करेगा एक दूसरे का साथ for the formation of the product, that number is called molecularity of the reaction. For example, this is a reaction ammonium nitrite. How many molecules? 1 mole. So molecularity of this reaction is how many? 1. तो stoichiometric coefficient for this reaction also 1, क्योंकि ammonium nitrite कितना मोल है? 1 mole. So it is an example. Hydroiodic acid produces hydrogen and iodine. So how many molecules of hydroiodic acid is participating in this reaction? This is an elementary reaction. How many hydroiodic acids molecules are participating in the reaction? 2. So molecularity is equal to how many? 2. So stoichiometric coefficient for this reaction also 2. So particular एक elementary reaction में जितना stoichiometric coefficient होगा that is equal to molecularity of the reaction. Similarly, nitric oxide reacts with oxygen. 2 moles of nitric oxide reacts with 1 mole of oxygen to produces nitrogen dioxide. So 2 plus 1, how many molecularity of this reaction? 3. And stoichiometric coefficient for this reaction also equal to 3. So when molecularity of a reaction is equal to 1, then that reaction is called unimolecular reaction. जब molecularity 2 होता है reaction is called bimolecular. जब molecular 3 होता है, molecularity 3 होता है, reaction is called trimolecular. लेकिन molecularity of a reaction rarely exceed 3. मतलब ऐसा reaction rarely मिलता है जिसका molecularity 3 से ज़्यादा होता है. So next topic, what is the differences between the order and molecularity? Order and molecularity का बीच में differences क्या है? So order of a reaction is an experimental quantity. According to our previous discussion, it is observed that किसी भी chemical reaction का order experiment करके determine किया जाता है. जस्ट हम लोग रिएक्शन को देख के एक रिएक्शन का ऑर्डर और एक रिएक्शन का रेट एक्सप्रेशन नहीं लिख सकता है. सो ऑर्डर ऑफ ए रिएक्शन इज एन एक्सपेरिमेंटल क्वांटिटी. पर्टिकुलर एक रिएक्शन के लिए ऑर्डर एक्सपेरिमेंटली डिटरमाइन किया जाता है. सो ऑर्डर कैन बी 0 एंड इवन ए फ्रैक्शन. पर्टिकुलर एक रिएक्शन के लिए ऑर्डर टू होल नंबर होगा ही. एक रिएक्शन के लिए ऑर्डर 0 भी हो सकता है, एक रिएक्शन के लिए ऑर्डर फ्रैक्शन भी हो सकता है. लेकिन बट मोलिकुलरिटी कैन नॉट बी 0 और फ्रैक्शन. मोलिकुलरिटी टू होल नंबर होगा, लेकिन मोलिकुलरिटी कभी भी 0 और फ्रैक्शन नहीं हो सकता है. लेकिन फॉर ए रिएक्शन ऑर्डर 0 और फ्रैक्शन हो सकता है, लेकिन मोलिकुलरिटी 0 और फ्रैक्शन नहीं हो सकता है. Next difference between molecularity and order. Order is applicable to elementary as well as complex reaction. Order elementary and complex दोनों reaction से related है, दोनों reaction के लिए applicable है. लेकिन molecularity, whereas molecularity is applicable only for elementary reactions. So molecularity term is related to only what type of reactions? Elementary reactions. क्योंकि अकॉर्डिंग टू द डेफिनेशन ऑफ मोलिकुलरिटी, एक एलिमेंट्री रिएक्शन में जितना टोटल नंबर ऑफ रिएक्टेंट मोलिकुल रिएक्शन में पार्टिसिपेट करता है, दैट नंबर इज कॉल्ड मोलिकुलरिटी. सो मोलिकुलरिटी टर्म इज एप्लीकेबल only for elementary reactions, but order is applicable for both elementary and complex reactions. So this is the second difference between order and molecularity. So for a complex reaction, order is given by the slowest step. A complex reaction is completed in a sequence of steps. In a complex reaction, some steps are fast, some steps are slow. So एक complex reaction का order होता है, एक complex reaction के लिए order, एक complex reaction का order reaction का कौन से step से मिलता है? slowest step से मिलता है. And molecularity of the slowest step is same as the order of the overall reaction. Particular a complex reaction is completed in a sequence of step. In that sequence of step, particular one step क्या होगा? slowest step. So ये जो slowest step का जितना molecularity होगा, that is equal to order of the overall reaction. Overall complex reaction का order कितना होगा? ये जो स्लोएस्ट स्टेप का जितना मोलिकुलरिटी होगा, डेट इज द ऑर्डर ऑफ द ओवरऑल रिएक्शन. फॉर एग्जाम्पल, दिस इज a complex reaction. We have discussed about it. So this is a complex reaction. So it has been experimentally observed that this is the rate expression for this reaction. So according to the rate expression, H2O2 इनका एक्सपोनेंट कितना है? 1, और I माइनस इसका एक्सपोनेंट कितना है? 1. ये दोनों एक्सपोनेंट को प्लस करने से दिस इज इक्वल टू हाउ मेनी? 2. दैट मीन्स हाउ मेनी ऑर्डर ऑफ दिस ओवरऑल रिएक्शन इज इक्वल टू 2. ये जो कॉम्प्लेक्स रिएक्शन है, इसका ओवरऑल ऑर्डर कितना है? 2. कैसे मालूम चला? क्योंकि ये जो कॉम्प्लेक्स रिएक्शन है, इसका रेट एक्सप्रेशन दिया हुआ है. क्योंकि पर्टिकुलर एक रिएक्शन के लिए ऑर्डर बताने के लिए क्या देना पड़ेगा? रिएक्शन का रेट एक्सप्रेशन गिवन होना पड़ेगा. सो अकॉर्डिंग टू द गिवन रेट एक्सप्रेशन, हाउ मेनी ऑर्डर ऑफ दिस रिएक्शन? ऑर्डर इज इक्वल टू 2. सो दिस रिएक्शन इज कंप्लीटेड इन हाउ मेनी सीक्वेंस ऑफ स्टेप्स? जब एक कॉम्प्लेक्स रिएक्शन का डिफरेंट सीक्वेंस ऑफ स्टेप्स को दिखाया जाता है, दैट इज कॉल्ड मैकेनिज्म ऑफ द रिएक्शन. सो फॉर दिस कॉम्प्लेक्स रिएक्शन, the mechanism is this reaction is completed in 2 steps. In the first step, H2O2 reacts with iodide ion, produces water and IO minus. It is an intermediate. It is an intermediate, or it has been experimentally observed that the first step is the slowest step. This is the slowest step. So how many molecularity of the slowest step? Equal to 2. कैसे molecularity 2 हुआ? इसके आगे में नंबर 1 आयोडाइड आयन का आगे में नंबर 1 प्लस 1 2. सो स्लोएस्ट स्टेप का मोलिकुलरिटी कितना है? 2. देयरफॉर हाउ मेनी ऑर्डर ऑफ दिस कॉम्प्लेक्स रिएक्शन? ऑल्सो इक्वल टू 2. क्योंकि स्लोएस्ट स्टेप का जितना मोलिकुलरिटी होगा, दैट इज द ऑर्डर ऑफ द ओवरऑल रिएक्शन. सो ये ओवरऑल रिएक्शन है, ये कॉम्प्लेक्स रिएक्शन, इसका ऑर्डर कितना है? 2. सो स्लोएस्ट स्टेप का molecularity 2, therefore order of the overall reaction also equal to 2. So these are the differences between the molecularity and order of a chemical reaction. So difference between molecularity and order of a chemical reaction is very important for exam purpose. So thank you.